A diode is a two-terminal electronic component that conducts current primarily in one direction. It has low resistance in one direction and high resistance in the other. A semiconductor diode, the most commonly used type today, is a crystalline piece of semiconductor material with a PN junction connected to two electrical terminals. It has an exponential current, voltage characteristic, and semiconductor diodes were the first semiconductor electronic device. What are the types of diodes? There are many types of diodes such as light-emitting diode, laser diode, avalanche diode, Zener diode, Schottky diode, photodiode, and PN junction diode. This is a different diode and their notation. Next, difference between LED and photodiode. Number 1. LED is a light-emitting device, while photodiode is a light-detecting device. Number 2. LED is always operate in a forward bias mode, while photodiode is always operate in a reverse bias mode. Number 3. In LED, emission of light is a result of electron-hole recombination, while in photodiode, photon generates electron-hole pair. Materials used for contraction LEDs are gallium arsenide and gallium phosphate, while photodiodes are made up of silicon.
Photodiode. Definition of photodiode. A photodiode is one type of light detector used to convert the light into current or voltage based on the mode of operation of the device. It comprises optical filters, built-in lenses, and also surface areas. These diodes have a slow response time when the surface area of the photodiode increases. Photodiodes are alike to regular semiconductors diodes, but that they may be either usable to let light reach the delicate part of the device. Several diodes intended for use exactly as a photodiode will also use a PN junction, somewhat than the usual PN junction. Some photodiodes will look like a light-emitting diode. They have two terminals coming from the end. The smaller end of the diode is the cathode terminal, while the longer end of the diode is the anode terminal. Function of photodiode. The working principle of a photodiode is when a photon of ample energy strikes the diode, it makes a couple of an electron hole. This mechanism is also called the inner photoelectric effect. If the absorption arises in the depletion region junction, then the carriers are removed from the junction by the inbuilt electric field of the depletion region. Therefore, holes in the region move toward the anode, and electrons move toward the cathode, and a photocurrent will be generated. The entire current through the diode is the sum of the absence of light and the photocurrent. So, the absent current must be reduced to maximize the sensitivity of the device.
Next is light-emitting diode, LED. Definition: light-emitting diode. A light-emitting diode, which is LED, is a semiconductor device which can emit light when an electric current passes through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor material. Since light is generated within the solid semiconductor material, LEDs are described as solid-state devices. The term solid-state lighting, which also encompasses organic, distinguishes this lighting technology from other sources that use heated films or gas discharge. To do this, holes from p-type semiconductor recombine with electrons from n-type semiconductor to produce light. The wavelength of the light emitted depends on the bandgap of the semiconductor material. Harder materials with stronger molecular bonds generally have wider bandgaps. Aluminum nitride semiconductors are known as ultra-wide bandgap semiconductors.
Let's study the working of LEDs. When forward-biased electrons from N-type semiconductor material and holes from P-type semiconductor materials cross the potential barrier region and recombine in the active region, these electrons are in the conduction band and holes are in the valence band. As the energies of the conduction band and valence band are different, when electron-hole recombination takes place, the energy equal to the difference between two energies is radiated in the form of light. This difference is known as the band gap or forbidden gap energy, and the effect is called as electroluminescence. This forms the working principle of LEDs. Normally, LEDs with red, green, yellow, blue, orange colors are available. For LEDs, silicon and germanium is not used as their forbidden gaps do not allow light emission in the visible spectrum. Wavelength is too low. Thus, LEDs are made up of gallium arsenide and gallium phosphide, etc.
Function light emitting diode LED. Light emitting diode or LED is often abbreviated with electronic components that can emit monochromatic light when a given voltage. LED is a family of diodes made of semiconductor construction. The colors of light emitted by the LED depends on the type of semiconductor material used. LED can emit infrared light that is not visible to the eye, that can be used as an infrared sensor as found on the remote control TV or other electronic device. LED shape similar to a small incandescent lamp and can be easily paired with the electronic device. In contrast with incandescent lamp, LED does not require burning filament so as not to cause heat to produce light. Therefore, the current LED, which is small, has been widely used as a torchlight in LCD TV to replace the lamp tube, and is also widely used in digital technicals.
Next is laser diode. Laser diode is a PN junction semiconductor diode which converts electric energy into the light when external voltage is applied. Laser is an abbreviation of light amplification by stimulated emission of radiation. This is the symbol of laser diode. The symbol of laser diode is similar to the symbol of the light emitting diode. The arrow shows the light generated. Next, we will see the working of laser diode. First, energy absorption. The laser diode consists of both holes and electron. When the external voltage is applied at the PN junction, the electron absorbs some energy and get excited to higher energy level from lower energy level.
The electron remain excited for few nanoseconds before they combine with holes. This time is called recombination time. The second one is spontaneous emission. After the electron get excited and recombine with the hole, they again travel to lower energy level. While traveling to lower energy level, they emit photon in the form of electromagnetic wave, and the energy of the photon in the difference between the higher energy level and lower energy level. Next is the stimulate emission. As we need more coherent photons, reflecting mirrors are used at the either side of the PN junction diode. So the photons get trapped inside the junction and they stimulate the excited electron to combine with the hole before the recombination time, and thus photons are emitted.
Difference between LED and laser diode. An LED light emitting diode is a semiconductor device that emits light when an electric current is applied to it. The light emitted by an LED is not a highly directional, and the intensity of the light decreases rapidly as the angle from the source increases. A laser diode is a type of diode that is specifically designed to produce coherent monochromatic light. The light emitted by a laser diode is highly directional and has a much narrower beam than an LED. Laser diodes are often used in devices such as a laser pointer, CD and DVD player, and barcode scanner. In summary, the main difference between an LED and a laser diode is that an LED emits non-coherent, non-monochromatic light, while a laser diode emits coherent and monochromatic light. Next, a few differences between LED and laser diode. First, light output. LED emit no coherent, non-monochromatic light, while laser diode emit coherent monochromatic light. Directionally, LED has a wide and non-directional beam, while laser diode has a narrow and highly directional beam. Wavelength. LED typically emit light at a wider range of the wavelength, while laser diode emit light at a specific narrow wavelength. Efficiency. Laser diodes are generally more efficient at converting electrical energy into light energy. Brightness. Laser diodes are typically much brighter than LED. Color. LED are available in a wide range of color, while laser diodes are typically red or infrared. Cost. LED are generally less expensive than laser diode. Size. Laser diodes are typically smaller than LED. Application. LED are commonly used in a wide range of applications such as lighting and display, while laser diodes are typically used in applications such as data storage, telecommunication, and industrial cutting. Lastly, safety. Laser diodes are considered Class 3B or Class 4 laser product and cause eye damage if not handled properly, while LED do not have same level of risk.